Hello, my name is Ben Kim, and I'll be going over the main class and the JUnit test graph as well. So in this class, we have the adjacency matrix, where we have the same set of nodes for each the list and the matrix. So if I go ahead and run it right now, this is the result that we get. So here we have the graph for the matrix, and this is the result that we have for breadth first, and this is the result for depth first, and this is the list that we have. In the same graph representation, but in a list form, and it just shows like the order that it goes in. And this is the JUnit test that we have. So we went ahead and ran it for the breadth first, for the adjacency matrix, depth first, and the adjacency list as well. And if we go ahead and run all three of them, it goes ahead and checks out the result, or expected result, right here, comes out as clear. The expected result here comes out clear as well. And the expected result here, we just got rid of all the arrows and made the expected result like that. And that is about it. Thank you very much.
The adjacency list graph creates an array linked list called ADJ list. And then we have this constructor right here. The add node method creates another linked list, adds a node to that list, and then adds that list to the ADJ list. The add edge has two parameters of a source and a destination, and adds that destination into the ADJ list. And then the check edge Boolean method has a parameter of source and destination as well. And it's just to make sure that there is an edge between two nodes. Similarly, with the adjacency matrix graph, we have a node and a matrix with variable sizes. The add node simply just adds it, and the add edge initializes an edge as 1. That way, when we check the edge, if it's 1, there is an edge, and if it's not, it's false. And here, when we run our main method, we can see that the adjacency list prints out like this, and the adjacency matrix graph is right
And I'll be going over our depth first traversal and breadth first traversal. So this prints the current node and then sets it as seen, and then for every node slash or vertex, whatever you want to call it, and then if the node hasn't been seen, current or the adjacent node to the current, then you run it again. So then it runs the whole thing, and then here we make an array to keep track of what we've seen. We fill it with false, and then I made a temp value, made the queue, and then added start to queue, and then start equals true, so we've seen it, and then we print the first uh, the queue, first of the queue, and then we add to the queue, and then see mark it as seen. That's it.